Hello, you absolute legends. My name is Eric J. Choi, and I'll be going over explaining video 6.2 that goes over the intricacies of a frictionless piston in an insulated jacket and how adding little masses on top of the piston will change the pressure, volume, and temperature. And jumping right into the problem. A cylinder with a frictionless piston contains an ideal gas. The cylinder is placed in an insulating jacket and small masses are added as shown right here. The students are asked whether the pressure, temperature, and volume of the gas will increase, decrease, or remain the same. So this problem is a bit different from all the other explainer videos because the professor actually told us to read a report beforehand that actually incorporates this diagram and many others that shows the miscomings of how students interpret the knowledge that they were taught in schools. Rather it be they directly related some concepts, or they completely misunderstood the fact that some concepts in certain situations do not relate to each other whatsoever. So I will just tell you my answer first and I'll explain them one at a time. As a result of the small masses being added, the gas pressure will increase, the gas temperature will increase, and the gas volume will decrease. Now, this is my reasoning for the pressure increasing. If the system consisting of the piston and the masses added have a greater weight than before and it is at rest, then the pressure increases. Now, some miscomings that some people may have when they were asked to solve this problem, as noted in the report, is that they directly related the gas pressure with mechanical equilibrium. So rather than the actual weight of the masses being added, they considered the factors of the mechanical system itself, such as the height instead, rather than the weight being added, as I mentioned before. From what I saw in the report, this is the major issue that they had, other than mistaking the microscopic models of how pressure interacts with the system. As for the temperature, positive work is done on the gas due to the masses being added to the system, and the cylinder is insulated, so there's little to no heat transfer overall. So by the first law of thermodynamics, the internal energy of the gas has to increase, and thus the internal energy is proportional to the temperature. Now, some people, when they read the problem, they instantly think that the insulating jacket is something that will actively make sure that no temperature change will happen whatsoever, rather than preventing heat transfer. So if any changes to the system actually happen that cause a change in temperature, they believe that the insulating jacket will make that a moot point and it'll cancel out, rather than making it difficult for heat to transfer like it should. So when you are doing these kind of problems in an adiabatic process, so it means a thermodynamic process which has transfer of heat or mass between the systems and the surroundings, the temperature will change, even if the transfer of heat of mass between system and surroundings is blocked by the insulating jacket. As for the volume, it's quite simple because, as you can imagine, after more masses are added, the frictionless piston will decrease and it'll be at a lower state than the initial position before the masses are added. So the overall volume of the gas is decreasing. However, the mishap that people have with this concept is they're thinking about the particles of the gas and relating it to the volume of the gas, even though that's not true. So what they are arguing is all these particles are the exact same, whether it's in this state or if they're squished closer together in this state. And just because they have the same amount of particles in the same amount of space, in different amount of space, the same amount of particles automatically define that the initial volume and the volume afterwards is equal, even though it's not. You cannot relate volume with the particles inside of the gas. As written right here, is good, not to be confused between the volume and amount of gas particles. I think that's all there is to explain about this, according to the reports given by the Professor Tonito. So I hope you guys understood, and have a nice day, you absolute legends.